Hello, in today's video we will be looking at how to attempt circle theorem questions for GCSE Maths. This is a list of all the circle theorems that you will need to know in an exam. Feel free to pause the video and study them for later use. Now let's move on to question 1. We've been asked to calculate the size of angle POR. So if we connect those points up, O and R, and O and P, we see that this is the angle that we need to calculate. And if you recall, there's a theorem that says the angle that connects a radius, in this case OR, and a tangent, in this case the line PR, is 90 degrees. So we can mark this angle, ORP, as 90 degrees. We also know that the line OP bisects the angle QPR, which means that the angle OPR is equal to half of the angle QPR. And if QPR is 44 degrees, we can say that OPR is 22 degrees. So let's write that in. And now let's use one of the more simple theorems. Angles in a triangle add up to 180 degrees. So if we use the angles we already know, 90 and 22, we get 112, and then do 180 minus 112 to give an answer of 68 degrees. So there we go. That's our answer. Now let's look at question 2. The theorem that we need to use here is that the angle in a semicircle is equal to 90 degrees. There we go. That angle. So then, if we work out this missing angle in the triangle that I've just highlighted, we can say that 90 plus 34 gives us 124, and then 180 minus 124 gives us 56. So that's our missing angle here. But then we also need to work out the missing angle in this triangle now, which is x. So 61 plus 56 gives us 117, and then 180 minus 117 gives us 63. So x is 63 degrees. Now let's look at question 3. We have to calculate the size of angle y, which is down here. But if we use the theorem, two angles in the same segment, are, that's right, they're equal. So here we can say that the angle in the same segment, so that's our segment, we have 57 here, so this angle is also 57 degrees. Which means that in this triangle, we can add 57 to 78, which gives us 135, then do 180 minus 135 to give us 45 degrees. So that's our angle y, 45 degrees. Now let's move on to question 4. We've been asked to calculate the size of angle BCD. So let's draw that on. And how do we do this? Well, first, we need to find out this angle, BAD. If you remember, the angle at the circumference is half the angle at the center. And the angle at the center is 156. So half of 156 is equal to 78. So the angle BAD is equal to 78 degrees. And then we can use the theorem that opposite angles in a cyclical quadrilateral add up to 180 degrees. So we've got 78 on this side of the cyclical quadrilateral, which I've just highlighted here, and on the other side is this. So let's work it out. 180 minus 78 gives us 102. So angle BCD is 102 degrees. Now on to question 5. We need to calculate the size of angle CAD. Let's just draw that on quickly. You may have already noticed it, and that is that the shape A, B, C, D is a cyclical quadrilateral. So we can apply the cyclical quadrilateral rule, and you may have also noticed that the line AC is a diameter of the circle, meaning we've got two semicircles. So we can apply the semicircle rule twice as well, which means that this angle ABC is 90 degrees, as well as this angle ADC, meaning we can now calculate this angle here, or we can skip that. We can actually work out this angle instead. So 90 plus 24 gives us 114. So that's this angle plus this angle. And then we can do 180 minus 114 to give us 66. So that's our angle here. And then what we need to do next is we can work out this angle, which is 90 minus 42, which gives us 48. And then since this line and this line are both radii, we know that this angle is also 48 degrees. And we can work out the total angle of BCD to give us 66 plus 48, which is 114 degrees. And then since opposite angles add to 180, we've got 180 minus 114 again to give us 66, which means that our angle here is 66 minus 24, which is 42 degrees. If you noticed a quicker way to solve that, leave it down below in the comments. You can look through the question again, go back to before all the annotations and check it out. See if you noticed the quicker way. Finally, here's a little challenge for you to try yourself at home. Feel free to pause the video or even quickly scribble down the question and then look back at the page with all of the circle theorems on it and then attempt the question. And when you think you have the answer, leave it down below in the comments. Finally, I hope you found this video useful. If you did, please leave a like and subscribe for more videos like this.